All right, this is the Your Turn out of section 8.3. The first example here, we are going to take a look at factoring by factoring the traditional method. So we have a 1 here times a 2 as our factors of 2, and a 1 here and a 3 as the factors of 3. Now if I multiply 2 times 3 and start with the factoring by grouping method, I can see that the factors of 6 are 1 and 6 and 2 and 3. And I'm looking for those that give me a difference of 5, and so I would need the 6 and the 1. Now without actually doing the full-blown method to make 5 with 6 and 1, what I can do in this instance with the traditional method is to try to make the factors 6 and 1. So I'm going to start with my binomial here of 2x here and the x here, which are the factors of the 2x squared that belong in the first positions in your binomials. And then I'm going to place the 1 and the 3 so that my outside product is going to make 6 and my inside product is going to be 1. So you see this one here, the 2 with the 3, and the 1 with the 1, that makes 6 and 1, the products that we saw with the factoring by grouping method. And now I just need to make them the right sign. I need a positive 5. So that means I need a positive over here, so I get a positive 6, and I need a negative here, so I get a negative 1. And that will be my factorization for that one. Now let's move on to the second one. In the second one here, again, I'm looking at the 12 here and the 1 here. Now this one is just like if we had x squared plus 7x plus 1, or plus 12. The way I would factor that is I would focus on the 12, right? I'd say 3 times 4 and 1 times 12 and 2 times 6. And with those factors, I would need to make those that sum to 7, and that would be the 3 and the 4. Well, it works exactly the same way when the leading coefficient isn't 1 and the constant is. So what I need here is I need the 3x here and the 4x here. Those are the ones that make 7, right? And there will be 1s here. Now the only tricky thing is when factoring, when the leading coefficient's not 1 but yet the constant is that I have to watch signs. I'm still using this to judge that I have a sum of 7 and still using the 3 and the 4 to get the sum. But then I have to pay attention to this sign here, of course, and it's positive, so that makes this quite easy because they both get to be positive. But if it were a negative as the 1, then I'd have to be watching the signs to give a difference. All right, now that was part B. Now moving on to part C. This one's a little bit more challenging because I do have 10, which factors as either 1 and a 10, or as a 2 and a 5. And then 3 is prime, thank goodness, because that makes my life easier. Now if we do the factoring by grouping strategy, right, 10 times 3, my first and my last multiplied, that's going to give me 30. And then I would either have 1 and a 30, or I'd have a 2 and a 15, or I would have a 3 and a 10, or I would have a 5 and a 6. And the ones that are going to give me a difference of 13, that would be 15 and 2. So now not using this strategy of where I'm going to rewrite negative 13 as negative 15 plus 2, I'm going to use that as a jumping off point for the factors here and the factors here, making the products of 15 and 2. So with 1 and 10, there's no hope in making a 15 and a 2, so I'm just going to start with the 2 and the 5. So I'm going to have a 2x here, and I'm going to have a 5x here, and those are my first term's factors, right? And now I'm going to put in the factors 1 and 3 so I can make a product of 15 and a product of 2. Well, 3 times 5 makes 15, and if I put a 1 over here, then I get the other one. So you see this is my 15 here, and then here is my 2. So the difference of 15 and 2, that gives me a negative, and this is a y, right, because we have a y squared. Don't forget about that. And now I have a negative and a positive, so that I get a negative 15 plus a positive 2, and that one finishes that out. So now we'll pick up in the next video on part B down here.